A very good day to our grade 12 learners. Welcome to today's mathematical literacy lesson. My name is Mampani Kekana, and remember that this lesson is brought to you by the Gauteng Department of Education in collaboration with the Sabono Discovery Center. Boys and girls, we are now going to focus on paper 2 because paper 1 is now behind us, and I hope you enjoyed the paper. Okay, so it's now time to focus on paper 2. Okay, now in today's lesson, you should be able to identify the structure and the work topics in paper 2. So today our focus is going to be about the topics that will be covered in paper 2. Okay, now with regard to paper 2, you must expect the following topics. Of course, maps, plans, and other representation of physical world. Okay, that will count about 40%. It might be 35% or 45%. And then in terms of marks, it's going to be about 60 marks. Now, with regard to maps, plans, and other representation of a physical world, of course, this is what you must look at when you prepare yourself under maps, plans, and other representations. Of course, you must know the scales. You must know different types of scales. You must know how to use those scales to do the calculations. And then, of course, you'll be asked questions based on different types of maps. So that means you need to know different types of maps. Of maps. What is going to happen in this case is they are going to give you a map and then they ask you questions based on the map. So you need to know the maps as well. With regard to plans, of course, here we're talking about house plans, and then we're talking about elevations. We're talking about the side views as well. So under the plans, we are referring to the house plans and the elevations. Okay, and then for number 2, you must also go and prepare yourself for measurement. Now, measurement, we know that it's one of the challenging topics in Mathslit, or it might be a challenging topic in paper 2. Okay, but if you prepare yourself very well, this is one topic that you can actually do well as well. Remember, the cornerstone of measurement, together with maps and plans, it's actually just conversion. If you can master conversions, if you can be able to convert between millimeters, centimeters, if you can convert metric units, millimeters to centimeters, kilometers to meters, and so on, and then you can also be able to convert imperial units, convert between imperial units and metric units, inches to meters, inches to centimeters, meters to feet, miles to kilometers, and so on and so on. So that is what you need to master when you come to measurement. And then, of course, you must be able to convert temperatures, use the formulae of temperatures to convert between degree Fahrenheit and degree Celsius, or between degree Celsius and degree Fahrenheit. And then, of course, you must be able to calculate perimeter or circumference. You must be able to calculate area. You must be able to calculate total surface area. You must be able to calculate a volume or capacity when the formulae are given. So that is some of the subsections that you need to learn for paper 2 under measurement. So please make sure that even after this lesson, you go and consult your workbook, all the work that you have done throughout the year. Just please make sure that you check all those subsections. And then, of course, you're going to get about 7 to 8 marks of probability. So basically, paper 1 is going to be about maps and plans, measurement, and then as well as about 7 to 8 marks of probability. Now, with regard to the structure of the question paper, paper 2, again, we are going to have question 1. And then in question 1, you must expect questions which will count about 30 marks. Now, Boys and girls, you might have seen in paper one today that question one consists of the easiest questions that you can get across the whole question paper. This is where you must score all the marks. You must score all the marks. If it's 30 marks, I will say please make sure that you get the whole 30 marks. Even if you don't get 30 marks, but at least 28, 29, 30. But you see that question one actually consists of the easiest questions ever. And then, of course, question two, you're going to have a scenario or a context about maps and plans. Scenario about maps and plans. And then again, you are going to have question three, which is about measurement. Question three, it's going to have a scenario that is based on measurement. And then question four, you are now going to have a combination of measurement as well as maps and plans. So in question four, you should expect scenarios where measurement as well as maps and plans are combined. The same thing with question five. It's now going to be a different scenario from the scenario of question four. But again, in this case, you are still going to have questions that have got combination of measurement as well as maps and plans. So boys and girls, I hope you now have an idea of how the structure of paper 2 is going to look like, and you are also 100% sure of which topics or which subtopics will actually be in paper 2. Just make sure that you go and practice the correct topics. And then we haven't spoken about finance, but finance is going to be about 5%. 5%, maybe about between 8 to 10 marks of finance. But for me, it will not be necessary for you to go and study finance again, because you have already studied finance for paper one. So once you have already studied finance for paper one, just focus on the other topics that you're going to write about in paper two. But finance is just going to be about 8 marks. Okay, now we are now going to look at some of the possible questions or similar questions that you can expect in the examination. Similar questions that you can expect in the upcoming paper 2. So this one is a typical exam question. It was taken from KZN Prelim paper 2, September 2024. It's the floor plan for an apartment is shown alongside. Use the information on the floor plan alongside to answer the following questions. 1.1, write down the compass direction. Write down the compass direction of the bedroom from the kitchen or dining room. Now, when they say compass direction, they are now talking about cardinal points. In some cases, the examiner will use the word general direction. And in some of the learners, when they say general direction, they explain. General direction, they simply means compass direction. So they might use the word compass or the word compass direction or general direction. Then how do we use this? For the compass direction, it means somewhere on the map or somewhere on the plan, they must indicate the direction N, okay, or the direction north. So in this case, if you look at this part, it indicates where N is pointing. So you can see that N is pointing in this direction. I know that in most cases you find that N is actually face upright. Okay, it has been indicated in such a way that it is upright, but in this case it is slightly skewed. So if it's slightly skewed, it means you must keep it like that, and that is how you're supposed to complete your compass. So in this case, if we complete our compass, we're going to put it like this. Okay, then I know that this is north. Okay, so we say north, and then this side is going to be east, and then this one is south and west. So you know this one, you know the slogan there, it's never ever smoke weed. Okay, so this is north, this is east, this is south, this is west, and remember this is slightly skewed. Now write down the compass direction of the bedroom. So where is the bedroom from the kitchen? Where is the bedroom from the kitchen? So here's the kitchen and there's the bedroom. There's only one bedroom on this plan. So there is the bedroom. it's going this way, then you can see that it's on the eastern side. So this one is just going to be east. The answer is east there. Very easy. It's one of those questions that you cannot afford not to get them correct. And then this one is determine which rooms will receive the afternoon sun. Determine which rooms will receive the afternoon sun. So again, still with our compass, if we complete our compass, we still have east and we still have west, and then we have south. So we all know that the sun rises in the east. So from the east, it's going to go up. So in the afternoon, it will be on the other side of the north direction. So it will be on the other side of this point. So the sun will be on this side. So you can see if it's on this side, the room that will receive the sun, it's now kitchen or dining room, because this is the window and the sun will be on this side. So in this case, that is going to be the dining room or the kitchen. So this one is just dining or kitchen, or exactly as indicated is kitchen or dining. So this one, they just say determine which rooms will receive the afternoon sun. So in this case is the kitchen and the dining. It's only this one, because if you look at this part, there's no window there. There, it is the only place where we've got the window. Okay, then the next one, it's again the typical exam questions. It's shown alongside is the layout plan for a wedding venue. The venue has a reception area and a hall where the wedding takes place. Use the layout plan above, it's actually alongside, to answer the following questions. Then they say explain the term layout. Explain the term layout, but they say in the given context. So some of the learners, when they add the weights in the given context, they tend to get confused. But actually, think about a pure definition of layout. What is a layout? A layout is the view of a house, okay, or sitting arrangement or a house from above. Imagine your classroom as you see it from above. What are you going to see? Okay, so in this case, when we talk about a layout, we are actually talking about the view, how you view a sitting arrangement in the house. Okay, so for this one, you can see that this is how you will see the plan, okay, or the reception area from above. But now if we have to define it from the given context, we'll see this is the view of the reception area of the wedding. This is the view of the reception area from above. What you have to do in the given context, it means you just have to add the wedding place or the reception area. So explain the term layout plan in the given context. The word layout plan, it means how you see or how you view the plan from above. But in this case is how you'll view the plan or the arrangement of the area from the arrangement of the wedding venue from above. So this one is explain the term layout plan. View, this is the view of the reception. This is the view of the reception area from above. Okay, so the view of the reception area from above. You can actually just explain it using your own words. You don't necessarily have to follow exactly my answer, but your own relevant explanation will also be acceptable. Okay, and then the next one is use the layout to answer the following questions. Identify the type of scale seen on the layout. Identify the type of scale. So we all know that we've got two types of scales. We've got a number scale and we also have a bar scale. So from this one, if you check the scale, you can see that we actually have a number scale. Sorry, we've got a bar scale. So this one is a bar scale. So it's a bar scale. So with scales, it's either a bar scale or a number scale. So this one is a bar scale. Okay, then still on the very same question is measure the length of the scale and write it down. Measure the length of the scale and write it down. So in this case, the examiner is actually checking if you can use a ruler to do the measurement or to do the measuring. So this one is just a matter of taking the ruler. The examiner doesn't specify whether in millimeters or in centimeters. So what we can do, we can start by measuring in millimeters. So if I take my ruler, in my case, I've got, so if I take my ruler and then I've got between, it's 10, 15, so I've got about 17.5. So in this case, I've got 17.5. Let me double check it again. So I've got 15. So it's 11, 12, actually I've got 10, 15, 16, 17, 18, about 18. So this one is about 18 millimeters. So it's just a matter of measuring. So in this case, when I do the measurement, I get 18 millimeters. Okay, so the next one says, explain what this scale represents. Remember, we have already measured the scale. So in this case, I have indicated that the measurement is 18 millimeters. But on the scale, they've indicated 5 meters. So when I measure it from this point to the other point, I get 18 millimeters. But in actual length, it's actually 5 meters. So this one, it means 18 millimeters, it's actually 5 meters in reality. But they say we must explain. So you can say 18 millimeters on the plan, 18 millimeters on the plan represents 5 meters. 5 meters in reality. Okay, 18 millimeters on the plan represents 5 meters in reality, or you can say 5 meters on the ground. Okay, that is how I can explain this. Explain what this scale represents. It means 18 millimeters, the one that I've measured on the plan represents 5 millimeters in reality. That is how simple you can explain this. Okay, then in this question, the next one is Pilgrim's Rest is a small museum town in the Mpumalanga province of South Africa. This town is protected as provincial heritage site due to its historic value. Alongside is the map showing places of interest represented by star in this town. Use the information above to answer the questions that follow. Name the provincial road shown on the map. Okay, now if you look at the type of map that is given, that is actually a provincial map which is given in the form of grids. Okay, it's a provincial map which is given in the form of grids as well, or the grids are actually indicated on the map. Then now they say name the provincial road. Now, how do we know that a certain road is a provincial road? So we all have different roads. We know that if the name of the road is denoted by letter N, capital letter N, then it's a national road. And then if we see capital letter R, then we know that it's a regional or it's a provincial road. Okay, and then we know that with letter M, it's a municipal road. Okay, I've seen in some cases there's roads that indicate letter D, so those will be the district roads. Okay, so in this case, they say name the provincial road shown on the map. So if I look at this one, the provincial road, obviously it will be indicated by letter R. So in this case, when I look at this one, is R533, and this one is also R533. So the answer here is R533. Okay, remember it's not 533 rands, but it's R533. That is the name of the road. State the grid reference. So the grid reference, what do they mean by a grid reference? Remember, in this case, you can see that they have indicated the blocks on the map. Okay, so we've got different blocks there. We've got 1, 2, 3, 4, 5, 6, 7, and then we've got 1, 2, 3, 4, 5. Okay, so it's 7 times 5, so that will be about 35. We've got about 35 blocks here. So each block is actually a grid. Each block is a grid, and then in each and every grid, or in each and every block, there's a name of a place. Not necessarily in each and every one of them, but most of them have got names inside them. So there it indicates in which cell or in which block do you find a certain place. That is what they mean by a grid reference. In which block? So you have to identify the block, and the block can be identified by using the letter and the number. Like this one, we can say it's A1. Okay, this block it's B1, this one is C1, and then when I go to this one, I can say it's A3. Okay, so that is how you state the grid reference, or this is how you state the name of the block. So in this case, they say state the grid reference of Joubert Bridge. So if I look at the Joubert Bridge, is this one. Okay, so you must also be careful, because in some cases they will indicate, remember, the name of the place. They might use a star or they might use a dot. Okay, so we look at where the dot is or where the star is. Okay, because sometimes they might indicate the name and the name will actually fall into two blocks, so you might not know which one is the correct one. So the correct one, you look at the dot or you look at the star. So in this case, likely the name Joubert Bridge, it's in the same block as the star. So but we know that the name of the place is actually represented by the star. So the grid reference in this case will be B3. So we just say B3. Okay, can you see how easy it is? Very, very easy. So the grid reference in this case is B3. And then number 3.3, it's complete. The scale used in the map is called, okay, I have already explained different types of scales. Actually, we've got two of them. So in this case, you just have to look on the map and tell what type of scale is given. So if I check, okay, there is a scale, all right, there's a line there. Okay, so the scale in this case is a bar scale. So you just have to complete this one. It's a bar scale. You can just indicate the word bar or you can write it in full, but in this case we have to complete, and then this will be this is actually a bar scale. Okay, then number 3.4 is name the tourist attraction in D4. So D4 is now block D4, or a grid reference. The grid reference is D4. What is in D4? So if I go and check on my map, then I see this is D and this is 4. Okay, so D4, so it means it's in this block or it's in this grid reference, sorry. So if I look at this one, I can see that it is a store museum. Okay, so this one is a store museum. Okay, and then you can also indicate that this pilgrim, the name is Pilgrim's Rest. Okay, store museum. Okay, and then the store museum, the name of the store museum is Pilgrim's Rest. So you can just write the store museum, or actually this one, the store museum, is what is the examiner was looking for. This is actually what the examiner was looking for. That is number 3.4. Okay, then number 3.5 is Mpumalanga province covers an area of 76,495 kilometers squared. Okay, the area of the whole of South Africa is 1,220,813. calculate rounded up to 1 decimal place. Rounding, very, very important. You must know how to round. Okay, you must know how to round off. So this one is rounded up to 1 decimal place, the percentage that the Mpumalanga province make out of the whole of South Africa. So in this case, we know that Mpumalanga is 76,495 of the whole South Africa. So what we do in this case, we say 76,495. Then we divide it by the total area, the area of the whole of South Africa, which is 1,220,813. Okay, sorry, it's 1,220,813. Boys and girls, it's also very, very important that you know how to read these numbers, because the examiner might also ask you to write down these numbers in weights. Okay, don't make silly mistakes like I'm doing. So that is 1,220,813. Then we multiply it by 100%. Okay, but on your calculator, you take your calculator, you say 76,495 divided by 1,220,813. Okay, then you press the equal sign. After pressing the equal sign, you multiply by 100. You multiply by 100, you don't multiply by 100%. You don't press the percentage key on your calculator. Then in this case, I'm getting 6,265. Okay, let me verify it again. 76,495 divided by 1,220,813. I get 0,062, then I multiply it by 100. I'm getting the original answer. It's 6,2659064. So it's 6408. This is the percentage. That is the original answer. That is the original answer that I'm getting from the calculator. But I must also be careful. I must also check in the question, because they said that rounded up to 1 decimal place. If I have to round it up to 1 decimal place, it means I must keep 1 digit after the comma. 6,2. Am I going to leave this as 2, or is it going to change to 3? That will depend on the third digit. If this number next to 2 is 5 or more, then this will change to 3. But if this was less than 5, the 2 would remain the same. So in this case, I can say the answer is 6,3%. Okay, so rounding up to 1 decimal place is 6,3%. So it means in this case, there is a mark specifically for rounding. If you're going to leave it here, then it means you're going to lose 1 mark. Okay, because there must be or there will be a mark for rounding. Okay, then again, the picture alongside represents a South African map. Answer the questions below based on the map. Okay, name the 2 oceans on the map. So this one, it's one of those easiest questions. It's one of those easiest questions. You just have to look on the map and write down the name of the oceans. The names of the oceans are clearly indicated. We've got Indian Ocean and also Atlantic Ocean. So it's Indian Ocean, okay, and Atlantic. So it's Atlantic Ocean. So Indian Ocean and also Atlantic Ocean. So name the 2 oceans on the map. There we have indicated the names of the 2 oceans. Okay, that question again. So this one, I'm sure you should be able to answer it. Okay, what type of scale is shown on the map? So it can either be bar scale or number scale. So in this case, again, you can see it's a line that is indicated. So that one is also a, so it must be a bar scale. Okay, right. So remember, in some cases, they will indicate just a thin block, okay? Right, so with the numbers on top or at the bottom, so that will still be a bar scale. But in a case where they indicate a ratio, that will be a number scale, or you can still say a ratio scale if you want to. Then they say use the scale to calculate the actual distance in kilometers between Bloemfontein and Messina to the nearest kilometer. Okay, it's use the scale to calculate the actual distance in kilometer between Bloemfontein and Messina to the nearest kilometer. Now, where do we start with this one? In this type of a question, you must start by measuring your bar scale. How long is your bar scale? If you look at this, they have indicated that this is 250 kilometers. But you know that 250 kilometers, it's a very long distance. It's a very long distance. This 250 kilometers just indicated in reality, this is 250 kilometers. So if we measure it, now when you measure it, it doesn't matter whether you are using centimeters or millimeters. But usually if you are using millimeters, you get an accurate answer. Or millimeters are actually more accurate than centimeters. So for this one, if I take my ruler and then I measure the length of the bar scale, in this case, I get 10, 11, 12. I'm getting 12 millimeters. So it's 12 millimeters. After measuring the 12 millimeters, it simply means this 12 millimeters is the same as 250 kilometers in reality. So when I measure the length of the bar scale, or when I measure the length of the bar, I get 12 millimeters, and then I know that because they have indicated 250 there, it means this 12 millimeters, it's equivalent to 250 kilometers in reality. Okay, what is the next thing that I need to do? Now, the next thing that I need to do is to measure the distance between Bloemfontein and Messina. The distance between Bloemfontein and Messina. So, in most cases on the map, next to the name of the place, they will indicate either a star or a dot. Where the dot is indicated or where the star is indicated is actually where the place is. Okay, like in this case, if you look at this one, they say Bloemfontein and Messina. If you look at the Bloemfontein, there is the name. The name of Bloemfontein is very long, but next to Bloemfontein, there's a dot there. Okay, the dot indicates the position of Bloemfontein on the map. And then I must also look at Messina. There is Messina. Okay, the Messina is indicated. The name is a little bit longer there. So you can't measure where the name is. You have to measure where the dot is indicated, because the dot indicates the location of the place. So now what I'm going to do, I'm going to measure the distance or the length between Bloemfontein and Messina on the map using a ruler. Again, because you measured the bar scale in millimeters, we also need to measure the length on the map also in millimeters. So if I take my ruler, I put it on my map. Okay, just make sure that the first line on your ruler, in terms of the measurement, will be on the same level as the dot, and then the other one is. So when I do this, I get about just try to be, I get about, so it's 30, 31, 32, 33. So I get 33 millimeters. So it's 33 millimeters. That is according to the map that I have here. When I do the measurement, I get 33 millimeters. That is from Bloemfontein to Messina. Okay, Bloemfontein to Messina. I can just double check again. Okay. So Bloemfontein, of course, I've got 3. Okay, I've got 33. So it's 33 millimeters. Now I want to know the distance. What is the distance? What is the actual distance? Okay, now what I can do here, I can use the cross multiplication method. I can use the cross multiplication method. I'm looking for D for the distance. I'm using letter D, small letter D for the distance. Then I cross multiply. If I cross multiply, is 12 by D is 12D. and then it's 33 multiplied by 250. So 33 multiplied by 250, then I get 8,250. 8,250. Okay, 8,250. Never mind the units. Don't worry about the units, because if we are looking for D, in the end, we know that this D will be in kilometers. We don't have to worry about the millimeters. And what we have to be sure when we do this method, we just have to make sure that the same units are on the same side. Like the millimeters and millimeters are on the same side. So whatever we find on the other side will be having the same unit as well. Then I divide by 12. I divide by 12. Then obviously 12 divided by 12 is 1, or they cancel out, and then I get 12. I get D equals to 8,250 divided by 12. Then I get about 687. 687,5 kilometers. Okay, this is what I get based on the map that I have on my presentation. So the distance is 687,5 kilometers according to my measurement on the map that I have. So this is the actual distance, and I know that this is actually in kilometers. 687,5 kilometers. Okay, then the next question is, what is the probability as a percentage? What is the probability as a percentage of being in a country which is neither South Africa nor Lesotho from all the countries in the map? Okay, what is the probability, or determine the probability as a percentage of being in a country which is neither South Africa nor Lesotho from all the countries in the map? Now we need to look at the following. If you look on the map, we now need to check how many countries are indicated on the map. How many countries are indicated on the map? If I look at this one, I've got Namibia, I've got Botswana, I've got Zimbabwe, okay, I've got Mozambique, and what else? I've got Swaziland, I've got Lesotho, and then of course I've got South Africa as well. So you don't have to miss this. I've got 1, I've got 2, I've got 3, I've got 4, 5, 6, and then 7, including South Africa. Okay, now I know that for the probability is going to be over 7. But how many countries must I count? They say, what is the probability as a percentage of being in a country which is neither South Africa nor Lesotho? So neither South Africa nor Lesotho, it simply means I'm not supposed to count South Africa and Lesotho. Okay, I have to count other countries. So I don't want to choose South Africa and Lesotho, but I want to choose the other remaining countries. So the other remaining countries, obviously, is going to be Namibia, Botswana, Zimbabwe, Mozambique, as well as Swaziland. So I'm going to leave South Africa and Lesotho out. So how many countries are there? We've got over 7. 1, 2, 3, 4, 5, 6, 7, including South Africa. 7 including South Africa. So this is over 7, and then I'm going to have only 5. 5 out of 7. But we need to be careful, because they say this must be as a percentage. Remember, probability can be written in 3 forms. That is a fraction, that is a decimal, and that is a percentage. So in this case, the examiner, it's specifying, the examiner specifies the format of the probability. So we multiply it by 100. We multiply by 100%. Then we say 5 divided by 7, multiply by 100. Then I'm getting 71, 428,57148. And this is in the form of a percentage. If you look at this question, the examiner doesn't specify the rounding, 71,428. So if you round it off, it's up to, if you round it off to 1 decimal place. But in this case, it's very important that you must first round down the original answer. So the original answer is this one on the calculator. Now you can round it off if you want to. Now rounding it off to the nearest percentage is going to be 71. because the first digit after the comma is less than 5. So therefore, this will remain the same. If we want to round it off to one decimal place, we look 71,4. Is it 4? Is the 4 going to remain the same, or is it going to change to 5? It will remain the same because the digit next to it is less than 5. If you round it off to two decimal places, we've got 4,2. Is it going to change to 4,3? Let us look at the digit next to it. The digit next to it is 5 or more. It means this will change to 4,3. Okay, but in this case, we can just round it off to one decimal place. That is 71,4%. Okay, the examiner didn't specify the rounding, so first write down the original answer and then you can round off after that. Okay, then the next question is, a family from Bloemfontein visits Messina. They leave Bloemfontein at 7:45, driving at an average speed of 110 kilometers per hour. On their way, they have two breaks of 35 minutes each. Calculate at what time will they arrive at their destination. Calculate at what time will they arrive at their destination. Okay, you may use the formula distance is equals to speed multiplied by time. So in this type of equation, you must actually check what is given. You must check what is given. So in this case, we are given the speed. So we are given the speed, and then we need to calculate time. Do we know the distance? Because obviously in a question like this one, where you have to calculate either a distance, if you have to calculate a distance, it means somehow the speed and the time must be given. If you have to calculate time, somehow the speed and the distance must be given. Okay, there's no way examiner will ask you to calculate time and the speed and the distance are somehow not given. When I say somehow, it means there's a way of finding those values before you can do the calculations. Right, do we know the distance? In this scenario, the distance is not given, but if you look at the previous question, we actually calculated the distance. If you look at the previous question, that is question number 4.3. This is question 4.3. We calculated 687,5. So our distance is 687,5 kilometers. And then what is our speed? Our speed is equals to 110 kilometers per hour. Okay. Then what are we going to do here? We have to calculate time, but you must always be careful because the examiners, they like to play around with this formula. They say calculate time, but if you look at the formula, the way the formula has been presented, it's not the formula for calculating time. Then we go to our triangle. We know our triangle, that if you've got speed and it's distance over time. So if you want to calculate distance, you say speed multiplied by time. So this one is for calculating distance. And then if you want to calculate speed, you say distance over time. If you want to calculate time, you say distance over speed. So therefore, what are we calculating here? We need to calculate time. So our time will be distance over speed. Distance over speed. Then when we do the substitution, our distance is 687,5 and then divided by 110. So if I take this, I say 687,5, I divide it by 110, then I get 6,25. And this now time is in hours. 6,25 hours. So it means for driving only, it's going to take them 6,25 hours for driving. They leave Bloemfontein at 7:45, driving at an average speed of 110 kilometers per hour. Okay, but now remember they have to rest on the way. So for them to rest, they have to rest for 35 minutes, 2 breaks. So the 2 breaks is going to be 35 minutes multiplied by 2. This will give us 70 minutes. Okay, because this one is for driving only. But now remember, they are going to be delayed by taking a break. They are going to be delayed by how many minutes? By 70 minutes. Then we all know that 70 minutes, think about 70 minutes. If we have to convert it to hours, 70 minutes is 60 plus 10, 60 minutes plus 10 minutes. So this is actually 1 hour and 10 minutes. Okay, for driving only, they will take 6,25. Right, so they're going to take 6,25 hours. So now we have to add the 1 hour 10 minutes. Okay, now we need to check this 6,25 hours. Let me write it here, 6,25 hours. If I want to write it in hours and minutes only, if I want to write it in hours and minutes only, I'm going to have 6 hours plus a quarter of an hour, 0,25 hours. Because some of you tend to think that if it's 6 hours, 6,25, then it is 6 hours and 25 minutes. But that is wrong. It's not 6 hours and 25 minutes. It's 6 hours and a fraction of an hour. That fraction of an hour is 0,25. Then we've got 6 hours plus 0,25 of an hour. Think about this, 0,5 of an hour. Half an hour, it's how many minutes? It's 30 minutes, because you say half multiplied by 60. So this one is 0,25 multiplied by 60. So if you take your calculator, 0,25 multiplied by 60, then you get 15 minutes. So this is 6 hours and 15 minutes. 6,25 hours is the same as 6 hours and 15 minutes. Now the total time, it means they're going to take, total time will be 6 hours plus 15 minutes. Okay, plus what is the other one? The other one was 70 minutes. We said is 1 hour plus 10 minutes. Okay, then in the end, I get a total of 7 hours plus 25 minutes. So 6 hours plus 1 hour is 7 hours, and then 15 minutes plus 10 minutes will give me 25 minutes. So all in all, they are going to take 7 hours and 25 minutes. They are going to take 7 hours and 25 minutes. So if I check my time there, they are going to say 7:45. Now if it's 7:45, and then now I have to add 7 hours and 25 minutes, what will be the time? What time will that be? Now if I say, let me write it, 7:45, and then I add 7 hours 25 minutes. So if I say 45 plus 25, 45 plus 25, so 45 plus 25 will give me 70. 45 plus 25 will give me 70. So it means for this one, I'm going to have I'm going to take from that 70, I'm going to take the hour. So it's going to be 10. So it's 10. And then the 1 hour, the 60 minutes will now be 7 plus 7, which is going to be 14. And then 14 plus 1 is 15. So they are going to arrive at 15:30. They are going to arrive at 15:30. So from 7:45, I add 7 hours 25 minutes, and then it means they are going to arrive at 15:30. That is 10 minutes past 3 in the afternoon, if they take 7 hours and 25 minutes. It's a very long one, boys and girls. So let us please ensure that in this type of questions, we actually be patient. We take our time, we check, we make sure that we calculate everything. But the most important thing in this case, you have to check what is given, and make sure that you use what is given correctly, so that in the end you get the correct answer. So this is the answer. The answer for this one is 10 minutes past 3 in the afternoon. Okay, then the next type of question. It's the picture and diagram below represents an American cool drink can, and then note 1 inch is equal to 2,54 centimeters. 1 inch is equal to 2,54 centimeters, and then use the information above to answer the questions that follow. 5.1. Show with calculations that the volume of the cool drink is 382 cubic centimeters. This must be cubic centimeters, right? You may use the following formula. Now, our answer must be in centimeter cubed. Our answer must be in centimeter cubed. Let us look at our diagram. In our diagram, from the formula, we need to know the radius, and we also need to know the height. The height is given. The height is 12,065, and then the 12,065 is in centimeters. And we've got the diameter, which is 2,5 inches. Okay, this diameter, we can first convert it to centimeters. If 1 inch is equals to 2,54 centimeters, then we've got 2,5 inches. We cross multiply. Now we want to know the diameter. I'm going to use letter D again, but in this case, letter D is for diameter. So my diameter will be, I cross multiply, D multiplied by 1 is D, and then 2,5 multiplied by 2,54. So if I take 2,5 multiplied by 2,54, I get 6,35. So this is 6,35 centimeters. I have now converted the diameter to centimeters because my answer must be in centimeter cubed. So in order for my answer to be in centimeter cubed, everything that I substitute into the formula must be in centimeters. Okay, 3,142 times radius, so this must be a square, sorry, so this one must also be a square. Then let's check, do I have the radius? I don't have the radius, but I've got the diameter. I can get the radius from the diameter, so therefore the radius will be 6,35 centimeters divided by 2. So 6,35 divided by 2, then I get 3,175. 3,175 centimeters. Now I have the radius. Do I have the height? Yes, I do have the height. The height is given there as 12,065. And then you have to take the values as they are. You don't round them off. You take them exactly as they are. And then you do the substitution. Then from the formula, when we do the substitution, we've got volume equals to 3,142. And then it's times the radius is 3,175. 3,175. So please, most of you forget to square it. Okay, so you must make sure that you square the radius as well. So that is 12,065. Okay, both the radius and the height are now in centimeters. So that means my answer will be in centimeter cubed. So I can use my calculator. 3,142 multiplied by 3,175. You must square it, and then you multiply by 12,065. Okay, so I'm getting 382. 382,138,651. 8651. Then the answer is in centimeter cubed. What was my question? My question was, show with calculations that the volume of the cool drink is 382 cubic centimeters. You can see that from the answer, if I round it off to the nearest whole number, indeed the answer is 382 cubic centimeters. So that is how I can show it. So in this case, it means the value is actually given. You just have to show how they got that value by means of calculations. So in this case, indeed, the volume is 382 cubic centimeters. Okay, then the next question, it's the can is only filled to 95% of its volume. Calculate rounded up to the nearest milliliter the volume of the can. Then again, they say note. So that means this is the conversion factor. Our conversion factor must also be 1 cubic centimeter is equals to 1 milliliter. So it means we need to convert that volume to milliliters, but it must only be 95%. So 95%, I would say 95% of 382. 382 cubic centimeters. So this is the same as 95 over 100 times 382 cubic centimeters. Then you can use your calculator. 95 divided by 100 multiplied by 382. Then I get 362,9. 362,9 cubic centimeters. Right, but now I need to convert. You can see that in this case, they gave me a conversion factor. It's 1 centimeter cube is equals to 1 milliliter. If it's 2 centimeter cubed, that will be 2 milliliters. If it's 5 centimeter cubed, then that will be 5 milliliters. If it's 3 centimeter cubed, that will also be 3 milliliters. So, but in this case, we've got 362. So therefore, this is the same as 362,9 milliliters. Then now we need to round it off to the nearest milliliters. To the nearest milliliters, 362. It's either going to remain the same or it's going to change to 363. So this will change to 363 because the first digit after the comma is 5 or more. So this is 363 milliliters. So that is how we're supposed to do this question 6. Right. So I hope so far so good, boys and girls. These questions look very, very easy. So if you can go and prepare yourself for Monday's examination, you'll also find them very, very easy. Okay, then this is another typical exam question. It was taken from Free State Prelim. It's a farmer in the United States of America uses the containers below to store and supply milk to local factories. Okay, and then they say note. There you are given the conversion factor. 1 gallon is equals to 4,546092 liters. 1 inch is equals to 2,54 centimeters. 1 milliliter is again equals to 1 centimeter cubed, similar to the previous one. Use the information above to answer the following question. Convert 55 gallons to liters. Let us look at the conversion factor. We are given that 1 gallon is equals to 4,546092 liters. Okay, we don't round it off. Okay, we take all the digits as they are. What are we supposed to convert? We have to convert 55. So therefore, 55 gallons, we want to know it's equal to how many of this. Okay, convert 55 gallons to liters. So now we need to do the conversion. So if I do the conversion, I can just convert the 55 gallons to liters. So this one I'm looking for the liters. Okay, you can use whatever letter to do the conversion. We can use letter C, okay, for conversion. Okay, then we're converting, but we know that our answer will be in liters. We can use any letter. If you want to use X, you're also welcome to do that. Then if we cross multiply, we know that C multiplied by 1, we get C, and then it's 55 multiplied by 4,546092. Okay, make sure that we wrote it down correctly. There's 4,123,456. 1, 2, 3, 4, 5, 6. 6 digits after the comma. Then if I multiply, I say 55 multiplied by 4,456,092. 55 multiplied by 4,456,092. Very, very important. I'm just double checking for in case I didn't miss one value, because if you miss one digit, then the answer will be totally incorrect. Okay, so when I do it on my calculator, I get 245, 0.03506, and it's now in liters. I have converted, but there's also a question that I have to answer there. Round your answer to the nearest whole number. In the end, this must be to the nearest whole number. 245. The first digit after the comma is less than 5, so therefore this will remain the same. 245 liters. That is the answer for number 6.1. Okay, then for number 6.2 is still on the very same one. It's write down 2 dairy products that can be produced using milk. Write down 2 dairy products that can be produced by using milk. I think, boys and girls, this one is very, very easy. I think most of you are eating these products every day. So it can be yogurt. Okay, of course. Yeah, I hope the spelling is correct. I'm eating this almost every day, but I hope the spelling is correct. And then we've got, of course, cheese. I think you can also think of many other products that are produced by using milk. So this would be an easy one as well. Okay, then, okay, I think this is a similar question. So 6.2 and 6.3, but we need to move on to the next one. The next one is 6.4. Show through calculations that the IBC total can hold more than 310 gallons of milk. So now this one, we need to calculate the capacity of the IBC. So we must first calculate the volume. Okay, we must first calculate the volume. They say 310 gallons. So what we can do in this case is we can calculate the capacity in liters. We calculate the capacity in liters, and then after that we convert it to gallons. I'm going to write it here. First thing, the volume. Right, let's check. We are given the dimensions. In this case, the dimensions, we've got 48, we've got 40, we've got 46 inches. But in order to calculate our volume in centimeter cubed, we must make sure that everything is in centimeters there. Okay, now let us look at this. How do I convert inches to centimeters? Then 1 inch is equal to 2,54 centimeters. So I can just take 48, this one, 48 multiplied by 2,54. Okay, so 48 times 2.54, and then this will give me 121,92. 121,92 centimeters. That is the length in centimeters. Then I go to the width. For the width, okay, now the width, I'm going to have 40 multiplied by 2,54. So the width will be 40 multiplied by 2,54. Then I'm getting 101,6 centimeters. Then I'm going to the third one, the height. I take 46. I multiply by 2,54. You all know the method of conversion. So if I take 46, I multiply by 2,54 on my calculator. 46 multiply by 2,54, 116,84. 116,84 centimeters. Now I've got all the dimensions in centimeters. Once everything is in centimeters, I know that my answer will be in centimeter cubed. Then now I can do the substitution. My volume is, the length is 121,92. Okay, centimeters. I don't have to indicate the centimeters in the formula. The width is 101.6. And then the height is 116,84. Okay, 116,84. 116,84. Everything is now in centimeters. Remember, what is important in this formula is whatever you substitute there, everything must be in the same unit. Okay, then when I simplify that, I say 121.92 multiplied by 101.6 multiplied by 116.84. I'm getting a very, very big number. I'm getting 1, 2, 3, 4, 5, 6. I'm getting 1 million. I'm getting 1,447,305, comma 492. Now my answer is in centimeter cubed. Okay, right. So from this one, they say that I need to compare this. I need to compare this one. So if it's 310 gallons, I've got 1,447,305,492 centimeter cubed. But I know that centimeter cubed is the same as milliliters. So automatically this will be the same as 1,447,305,492, and then milliliters. You see there, 1 milliliter is equals to 1 centimeter cubed. 1 milliliter is equals to 1 centimeter cubed. So immediately this will just change to milliliters. But in the end, I need to check if this is 310 gallons. So for me to convert to gallons, my answer must be in liters first. Okay, let's see. How do I convert milliliters to liters? How do I convert milliliters to liters? I have to divide by 1,000. So I take 1,447,305,492. Then I divide it by 1,000. Then after dividing by 1,000, I get 1,447. Then it's 0.305492. And then it's now liters. I'm not rounding anything off. Now, I've got 1,447,305,492 liters. I need to convert it. How do I convert this? If I want to convert from gallons to liters, I'm going to multiply by this. Remember how we did that? We know that 1 gallon is equals to 4,6092 liters. Now I need to do the conversion. What do I need here? I need to know the gallons. But what do I have? I've got 1,447,305,492. I'm not rounding anything off. We are not supposed to round off until we get to the final answer. Okay, in this case, then I'm looking for the conversion there. So what I can say, okay, I can use letter G for gallons, and then I cross multiply. If I cross multipy, it's G multiplied by 4, then it's 4,546,092. Then that is letter G equals to. If I cross multiply this, I'll still get the same thing. I get 1,447,305,492. Never mind my space there, please. Okay, 1,447,30492. Then I'm looking for gallons. Then I divide 4,546,092. I also divide that one by 4,546,092. I hope you can see everything that I'm writing there. Then I know that this one and that one will cancel out according to the cross multiplication method. Then I take 1,447,305,492. I divide it by 4,546,092. then I'm getting 318. So the gallons there is 318. That is what I'm getting. Okay, but if I go back to my information, they say show through calculation that can hold more than 310 gallons. So it can hold more than 310. Yes, indeed, I'm getting 318. So it means it can actually hold more than 310. Okay, so you just you need to indicate it can hold more than 310. More than 310. That statement is very important. 310 gallons of milk. So you have to indicate that. If it was less, you would indicate that it can't hold more than 310. It can actually hold less. But in this case, we can see that it can hold more. Okay. So it's also one of those long questions. Unfortunately, as much as you would expect to get the easiest questions, or as much as there will be the easiest questions in the question paper, there will also be those challenging questions. So you must also be ready for that. Okay, then the 6.5, they say the farmer decided to paint the total external surface area of the drum to keep it away from rusting. The spread rate of the paint is 2.5 square meters per liter, and the paint is sold in 1 liter tins. Calculate how many tins of paint will be needed to paint 1 drum. You may use the formula. Okay, calculate how many tins of paint will be needed. Okay, now how are we going to approach this one? We need to check. Once they say the spread rate of the paint is 2.5 meters squared, and then now we have to calculate the surface area. And then here, at least the examiner was very merciful to indicate that the surface area in meter squared. In meter squared, it means everything that we substitute there must be in meters. Everything that we substitute in there must be in meters. Unfortunately, it must be in meters. But if you look at our dimensions are given in inches. So it means we need to convert this quickly. First thing, we've got a diameter. Our diameter is given as 22.5 inches, and then the height is given as 33 inches. Okay, but in order to make it easier for us, these values, when we substitute them in that formula, we must substitute them while they are in meters. So it means we must first convert this to meters so that we can substitute. In the previous question, we saw that 1 inch is equals to 2.54 centimeters. Okay, and then what we did is we converted by multiplying. So we can still do it the same way. We can say our diameter is equals to 22.5 multiplied by 2.54. But remember, when we multiply by 2.54, our answer will be in centimeters. So this will be 22.5 multiplied by 2.54. Then I get 57.15, 57.15. And remember, this is now in centimeters. But I want these values in meters. Now I can convert these centimeters to meters. How do I convert from centimeters to meters? I divide by 100. If I take that, I divide it by 100, then I get 0.57. 0.5715. And this is now in meters. Right. So therefore, my radius will be 0.5715 divided by 2. Then that is 0.5715 divided by 2. Then I get 0.285 and then 75. Okay, Sorry about that. 75, 28575, and it's in meters. Now I've got the value of the radius, but I don't know the value of the height. The value of the height is still in inches, so I'll say the height is 33 inches. Then I take 33 and multiply by 2,54, and then 33 multiplied by 2.54, and then I get 83.62. No, 83.82. 83.82, and this is in centimeters. Again, but I can't substitute it into the formula while it's in centimeters. What I will do is I'll now convert it. Then I divide it by 100. Then I get 0.8362. It's now meters. I now have the value of the radius, which is this one. I now have the value of the height, which is this one. So I can do the substitution. Okay, so to do the substitution, I'll go back to the formula. The substitution there, I'm going to write it here, is 2 multiplied by 3,142 multiplied by, what is my radius? 0,28575 squared, and then is plus, then the other part is 2 multiplied by 3,142 multiplied by radius. My radius is still 0,285 multiplied by 0,28575, and then I also multiply by, what is my height? My height is 0,8362. I'm sorry, I don't have enough space there, but you do have an idea that in this formula I now have to substitute everything. I have substituted the radius. I made it to the power of 2. Then the next one, I said 2 times 3,142. I substituted the value of the radius, and I also substituted the value of the height. And then from there, you can take your calculator and simplify this. Some of you will simplify each part. So it means you will simplify the first part, you get the answer. You simplify the second part, you get the answer. And then after that, you add them together. So in order for you to get to the correct answer. Okay, so for this one, let me just round it up. So if I do it, I say 2 times 3.142 multiplied by 0.28575 squared. By the first part, I get 0. I'm going to write it here, 0,513, 310, and so on and so on, if you do it on your calculator. And then the second part will be, if I take that, I say 2 multiplied by 3,142, and then I multiply by 0.28575, and then multiply by 0.8362. So 8362, I get 1.50152, and so on and so on. So then from there, you add them together to get to the answer. Okay, so boys and girls, unfortunately, time is not on my side, but I hope you have benefited from all the activities that we have done, and this actually gave you an idea in terms of what you must prepare for Monday's question paper. Okay, please make sure that you go and study very hard for paper 2, because it's also a challenging paper as well. Okay, thank you very much for watching this lesson, and then I hope to see you next time. Goodbye.